Question of the Week from the Naked Scientists.
Hi there, welcome to Question of the Week. I'm Jenny Gracie, and this week we've been shining light on this question from Richard.
Why does a candle start to make more smoke and smell when it's blown out?
To shed some light on this question, I spoke with Duncan Graham, a professor of chemistry at the University of Strathclyde, to first of all find out how a candle actually works.
A candle looks simple enough. A block of wax with a wick, often a piece of string running through its centre, but you need three things to start a fire: fuel, oxygen and a heat source.
I also caught up with Ricky Carville, who teaches combustion and fire dynamics at the University of Edinburgh. He had this to add to how the flame keeps alight.
When a candle is burning, the energy from the flames heats up the wax, and while the wick does burn, it's actually the wax that fuels the flame and keeps it burning. The melted wax flows towards the wick and is drawn up into the flame. Inside the flame it's about 800 to 1000 degrees C, and the high heat breaks up the big wax molecules into smaller chunks. This process is called pyrolysis. Most of these chunks burn inside the flame and are turned into carbon dioxide and water vapour, which are both invisible and have no smell.
This process can also be called combustion. Duncan went on to explain it further.
If the combustion of the wax is 100% complete, then only light, heat, water vapour and carbon dioxide will be produced. However, we've all seen the sooty marks that can be left on the edge of a candle holder, or on a larger scale the black marks seen at the back of a fireplace heading up the chimney. This is due to incomplete combustion of the wax producing small carbon particles, which we call soot.
So that explains why we see smoke, but what about the smell?
The smell you get from a burning candle is due to the tiny proportion of pyrolysis products that didn't burn properly in the flame. When a candle is blown out, the flame stops immediately, but the wick and the wax are both still hot, so pyrolysis continues for a few seconds. The solid particles and smelly gases are produced for a moment, but with no flame to burn them, they rise like smoke. This is what we see coming from the wick, and this is why the smoke smells more with no flame.
It's the same process for burning any type of fuel. By this logic, and on a bigger scale, if we want a fuel source such as coal to burn more effectively, then we can carefully blow air onto it to increase the amount of oxygen. This in turn increases the efficiency of combustion, producing a cleaner flame and less smoke.
Thanks to Duncan and Ricky for helping us shed some light on that question. On the forum, we had contributions from Evan_AU and Petrochemicals. Both of them suggested that the hot flame breaks down the wax fuel source, and when the temperature isn't high enough, we get incomplete combustion. Next time, we're considering this question from Leah.
So why are some people good at imitating accents and doing impressions while others simply aren't? Obviously you can get better with practice, but why are some people born with the skill of imitation and some aren't?
But what do you think? You can email chris@thenakedscientist.com, find us on Facebook, tweet @NakedScientists, or join the debate on the forum at thenakedscientist.com/forum. Thanks for listening, and until next time, goodbye.